Okay, now hello for another video, and today we're starting talking about functions. So last time we finished our basic data structures course. Spoiler alert, we will need a little bit of adjustment to that and a little bit and to extend it a little bit. And as for today, we will talk about the theory of working with functions. So functions are basically the main thing in modern development, and there are different types of functions, and they have their own structure, and we really need to dig it up. So without further ado, let's start. I've already played with it, and I did first three lessons, but about the theory. We have different types. Basic function, you can initiate it with the word def, the name of the function, then in parentheses, you write the arguments that this function is going to work with. Don't forget to put a colon, then after the tab, you do all the logic. And pay attention to the word return in here. The word return means that this function is going to return something to here as a result. It definitely explains how to build the functions, but not how to work with them. So let's do something, right? So we'll define the function func, which is going to take some arguments like a and b, and what it's gonna go, it's gonna make it's gonna return a multiplied b. Basically, this is a function, extremely stupid one, but anyway. So how to make it work? Basically, easily. You should call function. To call function, you just need to print its name, and one day I will be able to type as a human being, and add some functions to it. So you see, when you start filling the arguments of the function, you have a little hint in here. It's when we are talking about VS Code with certain adjustments, so it really depends on the software you're working in. So of course, if we're multiplying it, we want them to be integers or floats, at least numbers, right? So let it be 4 and 7. And this is going to return us 28, but we don't know. How can we find it out? Well, there are two options. We can either print it, right? Allow myself for this cases. It's gonna be 29, right? To 28, sorry. Or we can make a variable c that is going to contain the result of working of this function, which is going to be spelled like this. So 7 and 8. No, not point, not point, not point. Alarm. It's going to be comma 8. And then we can print c. You see? Okay, yeah, it's 56 now. Moreover, it can not only return something. Some functions don't return anything, and there are some functions that don't need any arguments at all. So let's make those functions. Def func2 is gonna get nothing as an argument, and it's gonna return nothing as well. It can take something and not return anything, but anyway, you know. And it's gonna just make some code, right? It's gonna print hello, not hello, but hello. And so then we can put lots of different things to do in here, right? It can be a very complicated block of code, but anyway, we can just call for it to call a function without any arguments. You can just leave parentheses empty. And as you can see, we have hello and world as written in here. There are some functions that take some arguments but don't really return anything, so I can put a name in here and we can make it like this. And we will call it from with the name of Mozart. Don't know why, just because. Oh no, really, not in here. Come on. Hello, Mozart. So this is when it comes to just normal functions, right? But there are some adjustments possible in here. For example, for each argument, we can apply some default value. For example, Barry. No. Yeah, something like this. And we can call function with empty parentheses and with this. And as you see, hello Barry, hello Mozart. You see, when you do not have any value by default and your function requires some parameters, but you don't provide it while calling this function, this can cause a problem, and it will cause a crash in the function and in your whole program. So to avoid that, you can just make any default values for all the parameters you put for functions to work. So these are kind of the basics, but not all of them. You know, there are some functions that may take 1, 2, 3, 4 in eternity of parameters. We do not really need to place all the eternity of the parameters. We can just take args. So def func with args. And now, how it doesn't really matter how many parameters we will add in. We can do like let it be return sum of args. Don't mess it, because when you call when you initiate it as a parameter, you need to add this star sign, and when you use it, you don't really need to do it. Basically, that's another built-in function. What was some kind of an operator, but we won't really make it deep. So I want it 1 7 5 6 4 3. As you see, we definitely haven't written it anywhere in here, but let's see at the result. and it's going to be 95. So all these arguments were taken as a tuple. Why tuple? Because if you use it as a tuple. You may well, your interpreter perceives it as a tuple, which is basically a constant list. So it's kind of like this. That's a tuple. In Russian, it's called cortege. So pretty interesting structure, though I haven't worked with it a lot. But what if we need to use how many arguments, but named arguments? What if we don't wanna use just the list of parameters? We want them to be named. In this case, we can do it as well. We can do it dict, and it's gonna take 2 stars and quarks. As far as I know, these names are not required by the system. It's just a conventional thing, really. Just let me check if you, yeah, you can see everything. Well, so it's some kind of a conventional thing, and you don't really need to get focused on it. But to keep it simple, to keep it understandable for other developers, I strongly recommend you to leave it as quarks. And what will we take? We can do it like this. So our dict is gonna be a dictionary that is gonna take k with the value of b, and all this stuff is gonna be inside of for k v in quarks. And we need to put it one tab further, and then our function of course needs to return dictor. So c equals to dict out of name. It's gonna be name. Basically, what is this? String any. Okay. Ivan lost name. It's gonna be Kuznetsov, actually. And let's make it, I guess, was not closed. What do you mean? It was closed. Something strange is going on, really. It gives me a problem. Quarks is dictionary of string and any. We have string, we have any as which is a string actually. No. Oh, I guess it should be like this in here, no? Okay, let's keep it like this. We will just look for which is gonna get some quarks. Basically, we're going to just repeat this one, right? And return quarks. And after that, we will print qua will it work like that? No, it won't work like that. Like zero positional arguments before we're given. It's not a positional argument, it's a named argument. Come on. No. Invalid syntax. I understand that it is an invalid syntax, but like, how else do I do that? I forgot, I'm so sorry. Okay, you know what? I have to pause here, look for how to do it properly, and then I'll come back. So sorry. Okay, now welcome back. So I'm so sorry, but I tried to edit some of my videos and they failed. So as far as I won't be able to do that, we will have to pause it like this. So basically, you need to input quarks like this. Okay, now let's get back to our previous function, and we will take it. Dict with the parameters name Ivan, last name Kuznetsov, and we will have a dictionary with please. Too many values to what? Please. Okay, Vin Cooks. Too many expected to. I provided you with. Oh, okay. You know what? We won't use quarks so far, so we will just like. Yeah. This is a dictionary. I didn't really grasp the whole meaning of it, but whatever. I guess we will have a closer look at this possibility when we would really need that, and understand that maybe you need it for something, but not really now at all. And basically, this is everything our AI manual presents us with, but there are different types of function as well. So when it comes to generating something, right, as you see, we can not just make the full list of something and then store it all in our operating memory. It can be very consuming when it comes to millions and millions and millions of different elements of one list. We can just call for them one by one when it comes to generators. Basically, what is a generator? It's just a function. It may take some parameters, it may take no parameters. And instead of like just making the list from y to from 0 to n minus 1, we can just yield no yeah yield I. How are we going to use that? It doesn't return anything, as you see, but it yields. For this to work, we need to call this function. How? We will say next from the generate from gen, and we will print and we will cooperate it multiple times, just so as we can see how it works. Oh no. N is not defined. Sorry. It's let be 20. I forgot everything. I did it. Yeah, you see. Now you can see it. So when we do it multiple times, or we can do it in a cycle, of course, but through the one iteration of our program, we should take it doesn't work. I don't know why. Oh my god. Jeez. I don't know why. Let me pause it once again. Yeah, now I did pretty everything okay, but I forgot that this is a generator function and this is a generator. So when we apply it to the variable, and now if we print it, it will get the element it is currently on, remember that, and then it's gonna print the next one. So basically 0 1 2 3 0 1 2 3. That's a powerful thing. Moreover, you can make a generator in one line with generator comprehension. It is the same, absolutely the same as list comprehension, but we should use not square brackets but parentheses, and in this case L for L in range. 20, it's gonna be the same. The first generator here, the second generator here. So there are even more types, but I'm so messed up even with the one I've just told you about, that I wouldn't prefer to go further in here, right? So I guess that's all for today for the theory. And what are the tasks in this section? Number one, make up a function for counting factorial of a number. 2. Make up a function that's gonna check if the number is simple or not. Task number 3. Make up a function for generating the Fibonacci list. Number 4. Make up a decorator function for measuring performance time. We will do that. It's not that hard, but I don't remember correctly. Number 5. Make up a function for working with wrapped lists. Number 6. Make up a function for validating of email address. Number 7. Make up a function for working with dates. We can. Number 8. Make up a function for crypting the text. Interesting, huh? Number 9. Make up a function for working with exceptions. Interesting. Number 10. Make up a function for working with regular expressions. So we have 10 tasks, 3 of them are already done, and I will upload the video of me explaining how this all works pretty soon. I guess in the beginning of this week, maybe even today. As you can see, I have different even types in here, the different variants of working with one and the same task. As you know, when it comes to functions, you have lots of variability. So I'm sorry for the quality of today's video, as I had to pause and resume pretty often, but there was just too much information for me to process it for once. So well, some details just escaped from my head suddenly. And even if you're a dabbler like me, yes, you can mess something. You can be confused in some moments, but if you keep pushing, you have everything you want. Thank you very much. See you in the next video. Bye.